Hey everybody, MS Farzan here, and welcome back to this video series on learning JavaScript for digital tabletop game and web development. In this video, we're going to put together some of the knowledge that we've learned so far to create a simple dice roller using our JavaScript code and Node as our runtime. You might be saying, well, okay, this might be useful to have some sort of code dice roller where I can roll dice and run some simulations, but how does that help me in the long run for digital tabletop game development? Well, if we understand the logic now, then when we take this into, let's say, an interactive character generator that we build on a website, or we use it in the back end when we're developing an actual dice roller that works on screen in a game, or even something that the players never see that's running under the hood, we'll be using the same logic and just applying a user interface on top of that. So we need to learn these concepts now so that we're able to apply them later. Let's get started. We don't really need any of this code that we've written so far, so I'm going to go ahead and just delete it. And we're going to think about what would a dice roller look like. Well, if we take the physical model of dice and we think in a game like Dungeons and Dragons, or in one of my games, Entromancy, we have a 6-sided die, we have a 20-sided die, we have a 12-sided die. We need a way of not only conceptualizing these different types of dice, but we also need a way of randomization to determine when we roll one of those dice, what's going to happen when we get the outcome. So the way that we do this in JavaScript is by using a built-in function that is called math. So here's a way of thinking about this. I'm going to create a function that's called let d6 equals function, and it doesn't take any parameters, curly braces, and that will be my 6-sided die function. And then let's say that I want within that function, I'm going to say math.random. And what's really cool about Visual Studio or another code editor that might have some sort of JavaScript integration is that when you start typing, it will start auto-filling potential results that you might be trying to type. So like when I start typing math dot, I get all of these different potential things that could fill out the rest of my code, like math max returns the larger of a set of supplied numeric expressions. If I go down to random, it says return a pseudo-random number between 0 and 1. So I'm going to say math.random, and actually let's just say console.log math.random. And I have the parentheses after random, as you'll recall, because I am calling a function here. So I need that. I need these parentheses in case there was an argument that I needed to pass into those in between those parentheses. Save it, and you recall that I can press up to find the one of my recent commands, or just type in node log.js to run my script. Press enter. And I don't see anything here, and the reason why is because I haven't called this function, even though I've asked the function to log to the console. I haven't actually called the function anywhere, so I'm just going to say d6 and run it again. And then I see this number that is between 0 and 1, which is 0.17352, and then a bunch of numbers after it. And if I do it again, I get a different number, 0.414. And again, and what JavaScript or Node is doing for me is just supplying a random number between 0 and 1, which is pretty cool. But that's not really helpful, because that doesn't signify to me that I've rolled a 6-sided die and I've got, I'm expecting to get 1 through 6, not a number between 0 and 1. So one way of handling this is to say math.floor, and then wrap the math.random around it. And if I just type in math.floor and hover over it, Visual Studio will tell me that it returns the greatest integer less than or equal to its numeric argument, which simply means that when I pass in math.random as an argument to math.floor, math.floor will provide an integer for me based on that number, rather than a decimal number, which is what we have right now. So when I say math.floor and then run this code again, I see 0 and 0 again and 0 again, because it's supplying to me the integer that is closest to the number, to the decimal number that I've received, and the lowest integer. So that's why it's called floor. If you imagine 1 would be the ceiling, because that's the highest it could be, and floor would be the lowest integer, which in this case is 0. So if instead I say in this within the console log, I want to say math.floor 1 plus math.random, then each time I would expect to get 1. Let's actually separate these things just so we are understanding how this concept works. If I say let x equal 1 plus math.random. Remember, I'm declaring a new variable here within my function. And then I can say console.log x. Or we can even create some text here, a string around this, and say console log x is, and then plus x. And then we'll say math dot, let y equals math dot floor, and in parentheses x, and then console log y. Or if we're doing this right, we'll say y is, and then plus y. So let's see how this turns about for us. We'll say x is 1. Oh, we didn't put a parentheses here, so we're going to get a little bit of a weird number there. So we see x is 1.895386, and y is 1. We'll do it again, and we'll see x is 1.85, and y is 1. X is 1.735, and y is 1. That just shows us that we're randomizing a number. We're picking a number between 0 and 1, and then we're adding to it 1 to create x. And then y, we're storing the floor, or the lowest integer closest to that number, and that's 1 every time, which is great. That's the way that we're able to get an integer out of this math.random that JavaScript provides for us. Cool. So, but let's see if we wanted to create actually a function that multiplies by 6, so we get a random number between 1 and 6, inclusive. So rather than saying let x equals 1 plus math times random, let's just say 6 times math dot random, and see what we get here. Okay, so x is 3.2826, and then we use math.floor to get the integer that is closest at the lower end of those decimal points, also known as the floor, and we get 3. Let's do it again, and we get 0. Well, that didn't work exactly the way we wanted, but let's keep going. We got 5. We got 1. We got 1 again. We got 1. Getting a lot of 1s. 3. So on and so forth. We could keep doing this, and what we'll find is that we're continually getting random results, but they're between 0 and 5 rather than 1 and 6, which is not our intended usage here. So what we need to do is wrap this with a 1 plus 6 times math.random. And then we're going to get a number between 1 and 6 every time. The reason why is because when we're multiplying 6 by a number between 0 and 1, we're obviously going to get a number that's lower than 6 every time. And because of the way that we use math.floor, that's going to return a number that's between 0 and 5. So we just add 1 to the whole thing. And now when we run this, we get 2, we get 1, we get 3, we get 2, we get 1, so on and so forth. That's really great. So that's one way of handling the dice roller. And if we wanted to run a bunch of simulations, let's say that I have something in my game and I want to know how many times, although you could easily just look this up, or you probably already know the probability of this, but you could say, hey, I just want to roll this d6 100 times, and we're doing it 3 times here, and I run it. And then it gives me, I run a very basic simulation that shows me a spread of how many times I could potentially get a result by rolling this dice. This is a very simple example, and there are much heavier tools out there that will help you visualize this in a much more clean way. But a lot of them won't be very specific to your game, and I find it very useful to run simulations, of course, a bit more complex than this, but with this idea at its foundation, that I can create code that does all of the dice rolling for me, and comes out with maybe not every single permutation that would be available in a more complex scenario, but at least give me an idea of where I'm headed so that I can work on it before I bring it to playtesting. So let's say that the idea is that I want to create a more robust dice roller that not only I'm able to roll it multiple times, but I'm able to supply different numbers to it and have that outcome be something that I can work with. So meaning I could create a, if I wanted to, I could say, let x equals 1 plus 6 times math.random, and instead of console logging all this stuff, I could just say, go back to the way that we originally wrote this code, and just say, let x equals math.floor, and then wrap everything with parentheses. And so we're saying, let x equals math.floor, and then within the parentheses, 1 plus, and then parentheses again, 6 times math.random, the math.random function, and then console.log x. That's just it. We're doing the same thing here. We're just making it a little bit simpler and easier to read, and we still get the same result. It's just that I've now rolled the dice 3 times, and I don't have to look at x is and all these numbers. I just know that I've rolled a d6 3 times, and when I do it again, I get 2, 1, and 2, and I'm getting 3, 6, 6. So this is working pretty much as intended, which is great if I just wanted a 6-sided die to be rolled, and I could do let d20 equals function, let x equal math.floor, 1 plus 20 times math.random. Make sure I have enough closed parentheses that match the open ones, and then console.log x. And then instead of running d6s here, I could say d20, d20, d20. And then I get 10, 25, 7, 13, 5, and I've got my d20 roller. Yeah, I rolled 2 critical hits, which is awesome. So we're doing pretty well here. Yeah, so I could create two separate functions, and there might be a use case scenario where I might want to do that. And one thing that I want to note here is that I've within these curly braces, I've declared two different variables, both of which are called x. And ordinarily, you might think I shouldn't be able to do that. I shouldn't, in the same program, I shouldn't be able to declare two variables that have the same name. And by and large, that's true, except if we're dealing with different scopes. When I'm in between these curly braces, I'm in a different scope than between these two curly braces, which itself is a different scope from the parent scope, which is, or like the global scope, which is outside of the curly braces. We're not going to deal with that just right now, but just have it in your head that we'll talk about scope at a different time, and it will be important to keep track of our variables when we're dealing with different scopes. Not really important at this juncture. So instead of, we talked in a previous video about don't repeat yourself, one of the hallmarks of good programming. And in this case, I'm very much repeating myself with these two functions. And there are some cases where I might want to do that, but it might be easier just to have one function that is able to roll dice for me based on whatever number I supply it. So instead of creating a totally separate function here, I'm just going to rename this function and call it dice roller. I can delete these references to D20 down here, and I can delete the D20 as well. And instead of the function taking no parameters, I'm going to ask the function to take a number. And this is just a placeholder parameter. You can call it whatever you like. And instead of letting x equals math.floor 1 times 1 plus whatever, instead of this being 6, I'm just going to say number. So let x equal math.floor 1 plus number times math.random, and then console log x. Now, when I call dice roller, I'll provide an argument, and I'll say 6. And I'll do it again. Dice roller 6. And dice roller 20. Let's run our function, or run our script, and I get 1, 1, and 6. 2, 1, and 8. 2, 6, and 14. So the first two numbers, because I've provided a 6 to them, I'm getting a random number between 1 and 6. But the third call of the function, I've supplied 20 as the number that I want to randomize from, and I'm getting a number between 1 and 20. Well, that's great. So I've essentially created a reusable dice roller that I can just pass in a number as an argument, and that it'll give me a random number in between 1 and that number, which is awesome. That's exactly the functionality that we want to see. But let's think about this a little bit more fully, in that this might get confusing, because I'm like, well, obviously the 13 is between 1 and 20, but I'm not really sure what the first two, they could be between 1 and 6. I mean, they obviously look like they're below 6, but that also could be between 1 and 20. So let me just add a little bit of text here and say console log you rolled a D plus number plus period. Space. The result was plus x. You rolled a d6. The result was 1. You rolled a d6. The result was 2. You rolled a d20. The result was 19. So that's our simple dice roller. And by adding some strings in between these numbers and x, we're able to have a more clean representation of what those dice rolls were. Let's say that I'm tired of just like copying and pasting this over and over again for my simulation, and I don't want to have dice roller 20, dice roller 6 over and over again. Instead, I could just write a for loop that says for let I equal 0, I is less than, let's say we want to roll it 10 times, I plus plus dice roller. Let's do the D20 version. And we saved it and we run it. And it runs the for loop for us, and it keeps telling us that we rolled a D20 and the results were 13, 24. Man, I'm rolling a lot of 20s here. This is definitely very different from when I actually play role-playing games. But we see that by using a for loop, we're able to run this dice roller function. Right now we're running it 10 times. In fact, we could encapsulate this concept within another function and say let dice, let's call it dice simulator equal function, and that will take another number, and we'll say well, actually we can just copy and paste this, or cut and paste, and put this in between the curly braces, and we say we let I equal 0 and I is less than number I plus plus dice roller 20, and we can say dice simulator 10, and what should happen here is that our script will run a dice simulator, and it starting with I being less than I starting at 0, and then it will keep running until I is equal to the number that we provide it. So we pass in a number as an argument, and then it will run our for loop on our dice roller based on the number 20. Run it again, and we see exactly the same functionality. I don't get any 20s this time, but I am running the dice roller 10 times using a D20, which is awesome. That means that I have the beginnings of a dice simulator here, where the dice simulator itself works with this reusable code in the dice roller. But there's one more thing that I might want to do. I might want to have my dice simulator be able to pass in a number to this dice roller, so it doesn't roll a D20 every time. So what I can do is I can add a second parameter here. So I can say number, comma, we probably should use a different nomenclature here, because we might get a little bit confused. We could say number of times type of dice. And so rather than I being less than number, it should be less than number of times, the number of times that we want to type, that we want to roll the dice. And the dice roller, instead of 20, taking an argument as 20, we'll just say type of dice. And then now when we run our dice simulator, we need to pass into it 2 arguments, a number of times that we want it to run. So we could say 10, comma, and then a type of dice, we want to roll a 20, a D20. So when I run my dice simulator this time, it should run it 10 times, because that's the number that I've passed in as an argument, which should determine how many times the loop is run. And the type of dice that I want to run is the number that is going to be provided through this function to the dice roller, which itself takes this number and performs the random operation on it. I roll it, and I get the same functionality, which is great, obviously, because I have the dice roller and the simulator that I'm looking to run. But for me, it's really good because my code has become a lot cleaner. And if we had followed the path that we had started with, we'd probably have like 20 or 25 lines of code. Now we have 12 lines of code, and we could even refine this a little bit more further. But we have encapsulated or conceptualized exactly what we want to have with the dice roller, and written pretty clean code that is able to simulate it for us. And we can obviously change the parameters of how this should work and make it a bit more robust by creating a more fully fleshed out simulator. And I encourage you to do that as your homework for this video. Try to figure out something that will work for your game by changing some of the things that we've done here, and see what you come up with. I'd love to see them if you'd like to post them into the comments. And that's going to wrap it up for this video with our little dice roller. We've got one more video to cover with a couple of concepts called objects and arrays before we move on to splitting out into our tabletop game development and tabletop web development videos. So stay tuned for that. And I hope this video has been helpful for you. If it has been, please be sure to like it and subscribe to my channel for more. I'd love it also for you to check out my books and games at entromancy.com or nightpathpub.com/entromancy and help me get the word out about them. And we'll see you soon.